manufacturing, and after that we'll have an industrial visit in VNIT Nagpur. So before I welcome the speaker for today, I'll give a brief introduction of sir. Today's speaker is Dr. TVK Gupta sir. He's Associate Professor VNIT Nagpur under the Department of Mechanical Engineering. Sir has done his PhD from IIT Kanpur on advanced manufacturing processes, hard material machining, metal additive manufacturing, free-form surface machining. Sir has also a lot of published journals in this topics also. Currently also sir has published in metal additive engineering. With that, sir has also received a lot of honors and awards. One which is very important is an early career research award in the year 2017 from SERB DST, Government of India. Under sir, there are a lot of PhD students taking their PhD course. So with this, I would like to welcome sir and thank you sir for giving your time, valuable time for this session.
Everyone, good morning. Before I start my whatever the topic on which I am going to talk, I want to have a small introduction of each and everyone from which place you have come up. So that we will also have some introduction from your side also to me. You can start from there. You want? Yes. No need to stand, you can sit.
Good morning, sir. Myself Anjali Mandi. Good morning, sir. My name is Vanida Maikulkar. I am from Nagpur, Sri Sai Polytechnic.
Good morning, sir. My name is By-Prof.T. I am from AICTE. Good morning, sir. Myself Viraj. I am from CST.
Good morning, myself Nagpur from Mechanical Engineering.
Good morning, sir. And good morning, everybody. I am Ashish Bahale, Training Placement Officer, Sri Sai Polytechnic, Chandra.
Good morning, sir. Myself Sanjay Dhingra. I am from Sri Sai Polytechnic.
What is it?
Beginning.
Mechanical.
Good morning everyone. My name is Vijay Nagpur, electrical department from Sri Sai College of Engineering.
I am Prashant Tikekar from Sri Sai College of Engineering. I am from International Development.
Good morning, sir. I am Mahesh Mishra from Sri Sai College of Engineering Technology. I am from Nagpur.
Good morning, sir. I am Pramod Sahare, Department of Engineering. I will study in Nagpur. Then I am working as assistant professor. Good morning, sir. I am Mahesh Gupta, Communication Engineering, assistant professor. Nagpur College of Engineering, Technology.
Good morning, sir. Myself, Dilip from CPT.
Good morning, sir. Myself, from CPT.
Good morning, sir. I am Shri Shinde from Chandra. Good morning, sir. Myself, Gokul Kurawale.
Working as a lecturer in mathematics from CPCSS Center.
Very good morning, sir. Myself, Sonali Chahande. I am working as a lecturer at CPCSS Center.
My name is Rajeshwari Tuppu. I am working technical assistant at CPCSS.
Many of you people might have come earlier also.
But we are officially welcome.
Sir support only we could have arranged this function here. So on behalf of all our CPET family and all this, thank you.
Okay. My research area was not metal additive manufacturing. In fact, not additive manufacturing at all. Because when I done my PhD at IIT Kanpur, I worked on abrasive water jet machining. Abrasive water jet machining to fabricate micro channels for aerospace application. My interest was there in working for aerospace materials since beginning. Even in my masters also, when I was at VNIT Warangal, I was working on similar kind of work which is on machining edge. So it is something like this metal additive manufacturing. I was pushed actually that I have to work. So there are two different reasons. One is that already when I have done my PhD, I thought that there should be something else I should explore. So I was working on additive manufacturing during my tenure when I was working as a research engineer at IIT Nagpur for almost 10 years. But there I never worked on metal additive. I was working on FDM, all these polymers, and ABS plastic, PPCP and PP also. We work for variety of components, and mostly we have worked for different, that whatever is the shaft which they have, it's about 2 feet, 3 feet, and the diameter itself is also half meter. So half meter, if the tolerance is 1 mm, nothing matters for them. They do that, they say that distortion is there, we do finishing and we will get the component. Because they were also not aware that the distortion also will create some problem. Because their interest is that whether the component is working sufficiently for a period of time or not. Then again I searched and I researched for almost 2-3 days. I was trying to understand why this distortion is happening. Basically, this process is not developed for additive manufacturing. This process is developed for repair applications. But if suppose in a railway wagon, if you see, if some repair is there, if something is crack is there, what they do? They grind it and they weld it and they do a finishing process, it will work. But in a welding process, what happens is that the temperature is so large, and the room temperature is also very, whatever is the thermal gradient which you are going to see is very high. Because of these thermal gradients, there will be cracks which are going to happen in the component. But there in the railways, they are not bothered because structurally it is working fine. They do welding and everything. But similar thing, these people are also understanding. Though the technology, the laser cladding is a very high tech, and they are using for repair applications, they never thought that this can be used as a additive manufacturing process. So then what we have done is that, based on that understanding, I have written one project to the Department of Science, which is under Early Career Research. So fortunately, we got the project sanctioned, 40 lakh rupees, and it is for a period of 3 years, but it got extended by 1 year more, 4 years. So how this distortion can be minimized? There are only 2 possibilities: that you reduce the temperature when you are trying to deposit any material. So obviously distortion will go. But the temperature at which you are going to deposit this laser cladding process is so large, you cannot reduce. A low temperature or a low power you cannot use because the material will not melt. So what then we tried to understand, we have done series of experiments, continuously somewhere around 100 to 200 experiments we have done as a first set of experiments. Then the cladding, when we have done, we have observed that the distortion is there. But somewhere we have to target that how the temperature anyway you cannot control, but at least you can monitor and you can say that these are the other parameters where you can configure such that there will not be any distortion. Basically what happens is that if any component is heated, when there is a distortion, obviously there will be stresses inside the component. There will be inbuilt stresses in the component. Over a period of time it will crack. It will fracture it. So then our target is that how we can monitor the temperature and how the distortion can be monitored. Like that the proposal got sanctioned and we made our own setup. We made our own setup, how to monitor the distortion, how to monitor the temperature, how they can be controlled in a series, in a systematic way we have done. And then what happened? We have developed this system. That time also we were not thinking of working for additive manufacturing. We were only to understanding that this can be used for distortion monitoring and temperature monitoring, how they can be reduced in order to increase the service life of the component. The basic target is for mining industry. Initially when we started with a mining industry work. So in mining industry, if you see, they will be not be having very high temperature, but they will be working for high wear resistance. Even material, which is stellite 6 in this case, and you can work. So this 2.5-3 years work, we have given this is the same region. So then what they have done is that the same stellite 6 they have implemented for mining industries on the cranes actually, the crane if you see. So they have used for stellite 6, and there is one more material, nickel chromium boron silicon, that material also there. Then with these parameters they have deposited and they have seen an increase in the life of 300 to 400%. Whatever the parameters which you have suggested, they have done, they have seen that there is an increase of 300 to 400 times. Again, every 40 hours they used to replace the teeth. So then with this coating they have used almost for 2 weeks, 3 weeks also. And it happened and they were very happy. So then it's a single layer, double layer when we have work. But then working like this, we thought that when we are trying to build in an FDM process also, what is happening, you might have seen the different FDM process, different metal manufacturing process in the last 4 days actually. So in the FDM what we are trying to do is that the plastic you are fusing and you are depositing. Here also we are doing the same thing, we are depositing. So then we thought that why this process cannot be used as an additive manufacturing. Then the concept of additive manufacturing came in the year 2017 that we should work on additive manufacturing. Then I searched what are the various technologies available for metal additive manufacturing. And fortunately, people are working on laser cladding process where this can be used as an additive manufacturing. Because then we started working, we have submitted one more proposal, but this time the industry has given contribution. They said that additive manufacturing means we are going to participate. And that is for aerospace applications, purely we are going for aerospace application, which is Inconel 718. So we got a project about 80 lakh rupees we got from DST. Where 20 lakh rupees was given by the industry partner, 60 lakhs we got from DST. Then we started working and there we did not stop that. So in the last 5 years, we could do a significant amount of research where this can be used in aerospace industry, and we have published almost 25 top class journals actually. With this work which we have done with the support of DST and industry. This is built by the deposit or by the substrate. Now we are working. We started this work where we got some considerable amount of funding from DST to develop the machine actually, which we have developed in-house. I'll show you in the afterlife. So this is what is the background how we have entered into metal additive manufacturing, a hardcore machining process. Strictly speaking, I need to have a rectangular, the deposition. But that will not happen because the laser itself is the power. If you try to see the distribution of the laser, the Gaussian distribution is going to take place. So like that you are going to have this type. So it is not possible to get a perfect. Extra whatever they used to get, we used to do a grinding operation at the edges actually. So like that we have done for single tracks, multiple levels, single levels. So like that 4 different varieties also we made. Now what is happening is that you have a base material, on the base material you are depositing. But now what is happening, this base material and the material which you have deposited, they should also have good bonding edge. So it is not that mechanical bonding will remove any point of time, it should be a metallurgical bond. So then when the heating is only possible, then only you will have a metallurgical bond. So the grain structures, whatever is there inside the substrate is going to have a little change, and whatever is the grain structure of the component of the material which you are depositing, that goes inside the substrate. So you will have a good metallurgical bond. Now if you try to see, these are all multi-tracks. So you have 3 tracks we made, and how fast you have to use, and powder feed rate.
Okay. Now what do you mean by PV?
PV is P into V, P multiplied V.
Acha.
So power multiplied, that because combination parameters also we have considered. Power into V.
P you have done, V you have done, and I you have done, then PV also you have
PV
done.
combination. That is. Because when you have an equation, you will have combination of
Combination
individual
of
parameters.
You have to check, yes.
That also we have.
Sir, what will be the application of
A better adhesion with the substrate.
Sir, observations are made on the cross section of the component that we have taken.
Yes.
We are getting the cross section by ADM process. Does the ADM temperature play any role in the cladding and the substrate surface contact?
That is what I said. I was not talking about the temperature or the stresses developed during EDM cutting. The cross section only we are doing. Cross section, it's an image. We are not doing anything related to the material properties. They are getting or not?